Welcome to SanfordFlipMath. This is PreCalculus. We are wrapping up the chapter from Demana, Foley, Kennedy, PreCalculus, 4th or 5th edition. We're wrapping up chapter 3, which is about logarithms and exponential functions, logistic functions in there a little bit. And the focus on this last section that we are working on is all of the compound interest and annuity formulas. And what I want to do in this video is take a look at some compound interest problems, and really what we're doing is stuff that's kind of out of the ordinary. If you're looking for kind of normal, plain Jane, straightforward problems, then I really would refer you back to section 3.6a, video 3.6a, and there are some straightforward problems there, just how to manipulate the formulas, how to work with them, and you can pause on these screens if you want some quick examples. And then I did do one where we were solving for time, a doubling time specifically, and then we did that twice, once with regular compound interest and once with continuous. Okay, so the focus this time is same formulas, just doing a little bit different stuff. So again, refer back to the other video if you need to. All right, so I think we're doing maybe 3 or 4 examples, something like that. This shouldn't be too long. Okay, and I don't know what just died on me, so hang on. All right, well, after a quick pause, it looks like everything's working, so I'm just going to keep rolling. Hopefully this works. Okay, so we are depositing $2,300 into an account that is compounded monthly. So K times per year. So in this case, it's going to be 12 times per year. So K is 12 because it's monthly. I am actually going to use this formula. Okay, so I'm going to start dropping numbers in. Okay, so 2,300. 1 plus the interest rate. Well, it says what interest rate? So the problem is that I don't know the interest rate. So I'm going to put an R there. And we'll solve for that in just a second. Again, it was compounded monthly, so that monthly is 12 times per year, and it's going to go in 2 spots. And it says in 5 years, and so I want it to go to $3,000. Okay? All right, so here's the plan. I'm going to clean this up just one more step here. Probably worth noting that I really cannot combine anything inside these parentheses because I don't know R and I can't do 1 plus 12. The only thing I could do is make a common denominator, make one big ugly fraction out of that, but honestly I don't really need to. 12 times 5 is 60. That part I can do. Okay, I'm going to move this problem out of the way. We'll deal with it in a bit. Okay, sorry. Goodbye. Okay, here we go. Okay, so solving. My goal is, again, to get R by itself. Well, in order to do that, I need to start peeling things off from the outside. It's the socks and shoes example, and I'm not going to go through the whole thing again, but the idea is the last thing out here would have been, if I was following order of operations, if I was going to calculate this 3,000 somehow, I'd have to do inside the parentheses, then to the 60th, then multiply. So I'm going to divide by 2,300 first. Okay, so goodbye to that. Okay, so on the right side, I'm going to have 1 plus R over 12 to the 60th. On the left side, and I'm going to actually do my calculations here. So this is 3,000 divided by 2,300. Okay, so 3,000 divided by 2,300. Okay, and there it is, 1.304. Now, as I said in class, be really, really careful about rounding. 1.304. I'm going to write 1.304 here, but that's not really what I'm going to work with. Okay, I'm really going to be working with that whole thing. Okay, and you'll see how I'm going to do it. Okay, well, now the problem is, how do I get rid of the 60th power? Well, really what I need to do is a 60th root. Now, there are a few ways to type that into your calculator. Let me first start by writing the 60th root undoes the 60th power here. So this becomes 1 plus R over 12. Technically, there's an absolute value that happens here with a little plus or minus, and I'm not going to worry about it because I know that my goal is to have positive answers out of this anyway, so I'm really not going to worry about it. So I'm going to do the 60th root of that last number, Okay, so over here what I'm going to do is the 60th root. Now, to get 60th root, 60, then math, then what we're going to do is push 5, or you could scroll down to the xth root, and then I need that last answer I had. Well, the way I'm going to do last answer is toward the bottom of the keyboard here, above the negative key is answer. So I'm going to do second answer. Okay, and I'm just going to hit enter. Okay, and oh, I still have something going. Oh, I need to get rid of that. Sorry. Okay, so I'm going to hit enter. There we go. Okay, again, be very careful with rounding. So this says 1.0044. Again, I'm going to write 1.0044, but I'm really keeping a whole lot more than this. If I just round this to 1.0, my whole answer is going to get thrown off because I'm going to subtract 1, I'm going to multiply by 12, and it'll throw things off. Okay, just trust me on this. Minus 1, minus 1. So this becomes 0.0044, etc., equals r over 12. Almost done. Okay, and then I'm going to multiply by 12. Okay, now I didn't type any of that on the calculator, so I will in just a second. So r equals. So just a reminder that I have to subtract 1 and multiply by 12. Okay, so I'm going to do, from my last answer, minus 1 times 12. Probably worth noting that had I rounded this, this would be nothing now, right? If I would have just called this thing up here 1, then when I subtracted 1, I'd have 0, and 0 times 12 would be nothing. And really what it's about is this little nub in here. So I'm going to call this, now remember, my goal was to find a rate. Okay, so this is r. Well, I'm going to say r is, move the decimal over 2 places to make it a percent, 5 point. Now I'm going to want 3 decimal places in the percents. So I'm going to say 5.326%, because the digit after the 5 is more than 5. So 5.326%. Okay, so again, r equals 5.326%. Okay, I want to do the same exact problem again, only now with continuously. Okay, so this was all about compounding monthly. Okay, so here we go. Let me extend the page. Okay, cool. So again, I'm depositing $2,300. But this time it's compounded continuously. Well, continuously is this formula. I can't do infinite number of times of year as k, so I'm going to use, let me just kind of make a note of this off to the side. Okay, so the p-value is still the same. Okay, the principal, the initial amount, is still the same, 2,300. E, I still don't know r. I still want it to happen in 5 years, and ultimately I want $3,000. Now, again, if this is going too fast, you have a pause button. Okay, I just don't want the video to be 20 minutes, you know, past an hour or whatever. Okay, dividing by 2,300. Okay, this starts looking familiar at this point. So now I'm left with E. Now most people would write that to the 5r power. Okay, so I'm going to go ahead and type in 3,000 divided by 2,300. Okay, so let me hit clear here, and I want all of this ink to go away. There we go, cool. Okay, so 3,000 divided by 2,300, 1.304. Now that number should look familiar, 1.304. Now again, I'm really going to use more. Okay, so now I want the exponent to go away. I want to get at that exponent. Now this is, if the exponent has the variable, then this is going to be a log to get rid of that. So I'm going to do ln this time, natural log, because it's about e. So the natural log of 1.304, etc., equals, now log base e of e to a power is just that power. And so now I'm almost done. I'm just going to divide both sides by 5. Okay, so r equals, now just a quick reminder that your calculator is going to start parentheses, you need to end them, and then you're going to divide by 5. So natural log, and then divide by 5. Okay, so I'm going to do natural log of my answer, close parentheses, divided by 5, and alakazam, 5.314. Okay, so again, I want to make this a percent, and then I'm going to go to 3 decimal places, so 5.314%. 5.314%, I'm going to take it back to the other screen, 5.314%. I believe that was correct. Okay, just a quick little comparison here. 5.314% versus 5.326%. Not a big difference, but worth noting that I can get away with a slightly smaller percent on this one because I'm compounding more often. Okay, so 314, like pi-ish, 326. So they're both about 5%, but slightly higher if I'm only going to compound 12 times a year versus if I compound an infinite number of times in a year. Okay? All right, so that was both finding the rate. Okay? Just a quick reminder, this one I had to take a 60th root because the exponent did not have the variable in it. This one I had to do a log because the exponent had the variable in it. Okay? All right, let's pop to the next. Okay, annual percentage yield is a So what does that mean? Okay, let me slide this out of the way for a second here, and cool. All right, annual percentage yield means the percent growth in 1 year. Now, this says compounded daily. Now, what that means is I'm really going to earn more than 4% in a year. If I was compounded just annually, the percent growth in a year would be 4%. It'd be the same. If I can only compound once a year, then the annual percentage yield is whatever that percent is. If I'm compounding more often than that, I really make a little bit more than 4%. So let me just kind of tell you now, I already know the answer is going to be 4 point something percent. It's going to be a little more than 4% because I'm compounding more often. I earn interest more quickly. Okay. All right, so what we're going to do, what I'm recommending is anytime you do an annual percentage yield, we want to know the percent of growth. Well, if I put it, see, they don't tell me how much money to put in, so I'm going to recommend, if they don't tell you an amount of money to put in, I say make P be 100, because then any growth from 100 will automatically be a percent. Okay, so let's just take it for a spin and see what happens. Okay, so I'm going to put in $100, 1 plus 0.04, compounded daily, so again, that's 365 times a year, in 1 year. Okay, so I'm going to, K is 365 times how many years? 1. And so I'm going to find out how much this is, and then I'm going to find out how much it grew. Okay, so 100, 0.04, 365, I'm trying to remember everything. You're right. We'll see how it goes. Okay, so I'm going to hit clear. All right, let me get rid of my old stuff. All right, so $100, 1 plus 0.04, the interest rate was 0.04, divided by 12. I'm sorry, that's not correct. Daily. Let me just peek over there. Daily, yes. Whew, caught myself. So 365 raised to the, now normally I would use parentheses. This is on the new system for the TI-84, so I don't really need to anyway because it's going to hold it all in the exponent. But it was 365 times 1, which is just 365, so I'm just going to type. Okay, so this says 104 point all that stuff. 104.0808. Okay, so this ended up 104.0808, and then even more stuff. Okay, so here's the question. How much did it grow? Well, it was $100. So it grew 4.0808 per 100. So this is really already a percent. If I go to 3 decimal places, this is, so the APY, annual percentage yield, This is a way to compare accounts from one account to a different account. If I say 4% compounded daily, is that going to give me better interest than if I do 3.9% compounded continuously? I want a way to compare them, and that APY is a way to compare them. If I had an account that earned 4.1% compounded once a year, that would actually be better than this one, because this one has an APY of 4.08, not quite 4.1. If you're talking about depositing $100, that's not a lot of money. But if you're talking about depositing $1 million, any little bit makes a big difference. Okay. All right. Just want to do this one more time for compounded continuously. Okay. So continuously, remember, uses this formula. Okay. So I want to know how much does it grow? What is the percent growth in 1 year? Annual percent yield is always about percent growth in 1 year, and my recommendation is always use P equals 100. Okay, for this, because most of the time they don't tell you a P for this. Okay, so A equals P times E to the 0.04 times how many years? 1, because it's annual growth. Okay, so I'm going to type this in. Okay, 100 times E to the, okay, let me get rid of this. Okay, so 100 times E to the, well, I have an E to the button. If I just do a second ln, it's E to a power already. 0.04 times 1, don't really need the times 1. 104.081. Well, this is actually slightly better. Okay, so remember, this one had this top one had an annual percentage yield of 4.0808 technically. I rounded to that. This one is 4.0810 something even before I round. So this is ever so slightly better, and it's probably negligible. Okay, so let me pop back to the real screen here. Okay, so this was 104.081 something something. So the growth from $100 is 4.081. Again, that already is a percent because I based it on $100. Okay. All right. I think I am leaving it at that. Did that idea already, and I think we're good. All right. Well, leaving it at that. Next installment will be getting a little more interesting, and so this is all about compound interest right now. One deposit, a single deposit, and then analyzing what do we want to know from there. Okay. Thanks for watching. Talk to you later. Bye.